First I'll start high. IC pin number 13 is high, and then this one IC pin number 13 is low, and then you see PWM3 IC pin number 3 is setting 255. So I am able to detect, we are able to detect what we are clicking, which block we are clicking from PictoBlox. Now we have this idea which button triggers what signal. With that in hand, we can remove all the Arduino and bring our brand new Arduino Uno R4 egg and let it operate by PictoBlox. Are you excited? Hello friends. So we are almost there. We learned in the previous session what is man-in-the-middle attack, and we also did in the Tinkercad as a simulation mode, and today we are going to do it in real, but we will not tell as a attack because we want to do something ethically and something for a better thing. Hello friends, so welcome to another video. In the previous video we saw the man-in-the-middle attack, how it can be done using Tinkercad, and this time we will use the same concept to implement our new Arduino Uno R4 egg into the PictoBlox device list. So let's start. So in the previous few video I was explaining this man-in-the-middle attack where you and your friends is talking, Piku and Pihu in my example, and then somebody in the middle tapped the wire and then listening what you are talking. And there are two different ways. One is the destructive way, like they are actively damaging the packet that is passing from you to him, and the other one is just listening, not letting any of you know that something is going on in the middle. But how it is related in our PictoBlox Arduino Uno R4 support example. So in this case, the Piku or the one person, maybe the you, is the PictoBlox, and he is talking with the Arduino that you have connected with the PictoBlox and trying to send the block code. And the attacker or the person who wants to sniff the communication is going to be another Arduino that I will be showing you. And using this second Arduino, we will try to understand what exactly PictoBlox sends to this Arduino, the intended Arduino, when he really says reset digital pin something as high or something as low or anything. Oh, this one's supposed to be low. Okay, anyway, so once we understand what is the exact packet looks like, we will hard code it in this Arduino and we will perform some action, and then we are going to replace this Arduino with Arduino Uno R4 egg. Neither of this is a third one, because once we understand, we crack the code, we will not use Arduino Uno, because our objective was to use Arduino Uno R4 egg. So once we know what is the keyword they're sending, once for each block, we will replace all the Arduino with Uno R4. So okay, let's jump in. So I will go back to PictoBlox screen, and for example, this was the code, high and low, and then here is my device, you can see. And for the safety, okay, I have to connect it. I haven't connected it. So when you're connecting, you have to go to the device manager. It's the best practice. You might be knowing already what is the port number, and one time, and then next time you don't have to do that. But okay, let me do it. So I'm connecting this Arduino with my computer, and you see what is that coming new. Yeah, COM3 is already written Arduino Uno, so COM3 is the one. So here we'll select the board that I have already selected, and then here we will choose COM3. Yeah, see, there is a big hint. And I will upload the firmware first. Means my driver is going and sitting into the racing car, as per the previous 2 video back I explained. So it's uploading and done successfully. So now if I click on this green flag, you see the LED is blinking. That means the Arduino, I mean the PictoBlox had started sending the command through the serial port, and that should be available in port number 0 and 1, not 0 and 1. This is the receiver pin is port number 0 for Arduino. So receiver pin, exactly in the receiver pin, RX pin number 0, the data whatever his PictoBlox is sending to him will be available. So we have to sniff there, right? So for sniffing purpose, I have one more Arduino. I'll keep next to it, and let me go to my device manager one more time. And so 3 COM3 COM1 11 12 13 14, what is the next number coming in? Let's see. It should be 5, I know. Come on. So yeah, it's 5. CA is 340, made in China. Okay, so yeah, mostly both are in China, but they have some variations. Okay, so this COM5. Now because PictoBlox and this black Arduino is already connected, I cannot disturb this. If I disturb this, I will lose the signal. I will lose, they will be aware of I am there. So I should not do that. So what should I do? For that, I will use some other coding platform, Arduino, the Arduino IDE. So let me keep it next to Toby, because we are not looking for Toby right now. And you see, it's still communicating. Okay, so it's infinite loop, it will keep going. And in the meantime, let us connect to the hacker PictoBlox. So let's go to the tool. Port number 5 is the other Arduino, the blue color Arduino. This is the port number 5, and we have to send some command. Okay, so what should we write? One thing you have to understand, so if we use the hardware serial port 0 and 1, it will have some problem, because that is being used for multiple other work, like sending code, and there will be some heartbeat going on through which they are connected to the computer, and we have to use the serial port here to listen to what is there, what he is sniffing. So all this purpose, we cannot use the hardware serial port. So we have to create a software serial port, like we did in the very early video here. So let's include the library for the software serial port. So so let me copy it here. So this is the software serial.h that you have to use, and the syntax is this is the one. So this is the class inside software serial.h, and you are creating an object of that. So I'm not going to discuss the class and C++ and all these things. Maybe we can have a different video, but okay, this is the class, and then you are having the object with a constructor having pin number 2 and 3. So this is the pin you are allocating for the software serial. I am allocating 2 and 3, so 2 being the receiver pin. So as you know from last few video, when you don't want to disturb the communication, you should not use the transmitter pin. If you use that, they will be aware of. So pin number 2, 3 we are not going to use at all. Pin number 2 is what we are going to use. Okay, so with that, what we are going to do is, in the setup function, we are going to write this. So what is this? This is the hardware serial port, where we are just initializing so that we can listen to that. And this is the software serial that we just now initialized, and we are starting with this baud rate, and we're just sending a started message. Let's flush the code and see. We should be able to see the started here. Okay, now we will open the serial port and see. Oh, the baud rate have to be correct. See, otherwise it's not able to read. And one more time, and you see started. That means this print is coming. So far so good. Now we will write something in the loop to see if the hacker Arduino is receiving something. So this is the code where we are checking if the software serial is receiving something, if something is available, and I'll say I saw something. Okay, What I saw, we'll see later. So compiling the sketch. In the meantime, I will explain you. So pin number 2 we said, right? That's the receiver pin. So we are going to use the Hacker Arduino, blue Arduino 012 pin number 2, because that's the receiver, and we will connect to the 0121 minute came out. Yeah, we'll connect to the PictoBlox receiver. Why receiver? So see, we are connecting receiver with receiver. Why we should do that? And for that, let me tell you one thing. Whenever you are you are listening to a receiver, that means you are actually not listening to what the Arduino is sending. You're listening to what Arduino is receiving. That means you're actually checking what PictoBlox is sending to the Arduino. You understood, right? So you cannot put your ear on somebody's ear, but you can. When you put ear in somebody's ear, you listen the other party what he is saying to him. So that's the idea. Okay, hope you got the idea. So I'm not explain much. And with that thing, you see, you started receiving that start coming. So there is no new line. So let me do a print ln. So it will print in the new line and compile one more time. So hope you understood that idea. So we are connecting receiver with receiver pin, which we said so far in the video we will not do. We will connect always receiver with transmitter, but this is the time where we are doing receiver with receiver. And you see, it started coming because that's a infinite loop running from the PictoBlox. So if I go to PictoBlox and keep it side by side and stop this, it has some amount of data in the buffer, I believe, that is cleaning up. Is it really blinking that fast? Oh yeah. So what happened, once you see something is available, you have to read it. Until you read it, it will be available forever. So you have to say read bytes, and just for now I don't want to see what it is. I'm going to see, but right now not. So I just want to show you that if I say while software serial, same thing is available, until it's available you keep reading whatever is there in your buffer. I mean whatever is there you got from the serial code. So with that change, so what I'm saying is, once you see it's available, read it out. Once you read it out, next time it will not say it's available until PictoBlox is sending something. So read byte takes some input. So I will use not read bytes. Then I have to say how many bytes and all this thing. I don't want to complicate this. Let's keep it simple. And with that change, compiled. Now go back. Not connected. What's that? What's going on? Saying it's not connected. So let me check COM5. It's there. One more time. Okay. And it should first of all say started. So I will reset once. And started came. That means it's now listening. And because this loop is off, it's not receiving anything. Now I'll start the loop. And I see something. Now the frequency is slow, right? Because it's reading, and only after every 1 second it's receiving something. So it's saying in the same pace. So I'll stop it, and you see, stopped. Again I will start, and you see, it started. That means we are able to sniff. But what the PictoBlox is sniffing? Let's see. I mean, what the Arduino IDE is sniffing. To read that, here is the code we are going to write. So let me take little by little what I have already written. So this is the read, right? So now we want to really read what it is coming. So what we will do for that is we are going to hold this value to a variable. So we'll take it in a incoming byte and we're going to print it simply. Okay, serial dot print ln, or I'll say print, and then finally we'll do a print ln just to ensure that it's in the next line. So all the thing will be printed here and followed by one underscore, and then this is the incoming byte I'm going to print. So with this simple code we should be able to see what's coming. Okay, compile. Now the real magic starts. You'll see what's coming. So they're connected, right? We are connected and started. Message already came. Now I will click on this. See 202, 203, 202, 203. Nice. So we are getting some value, right? Now let me do one thing. Let me this scroll bar. Okay, now I just want to make it little bigger. Let me make it little smaller. Okay. So now in PictoBlox actually you can click on a block and it will send only that signal. That way we can isolate that what exactly is sending per signal, not for the whole value, because we want to isolate one signal and hack it. So let's click on this alone and see what's coming. 202, 203, 202, 203, 202. See, it's not consistent. It is expected to be consistent, right? But somehow it's not consistent. Every time a new number is coming, we cannot hack this way. It will not be consistent in that case. So what happened? Actually, what happened is, I think, let me check here. Technical feedback review about PictoBlox device driver installation. I think it is in Bluetooth settings. PictoBlox number. I don't see it here, but yeah. So the thing is, the baud rate, you have to match the baud rate, and the baud rate will be written somewhere here. I missed it where it is written. So PictoBlox is running in a baud rate. You should know the baud rate. So the baud rate is not 9600. It is this one. Okay, because it is this one, you are not able to read all the packets. You are missing packets. So suppose somebody is sending you 10 ball in 1 second and you are thinking he is receiving 4 ball in 1 second. So you will miss other 6 balls, or say 8 balls he is throwing and you are only thinking 4 balls he is sending. You will receive only 4 balls and in middle one ball will be missed. So that's what happened. So this is not the full packet, that's why you are not receiving. I changed the baud rate and I changed the baud rate here as well. And now let's see the magic. Compile the sketch. Come on. Down. Done. So let's clean. And now click on this and see. 255, 85, 502, 31, 13, 5, 1. Before we was only receiving 13, 12 like that. Now we got this whole thing. See, now it's consistent, right? So this is the value we were looking for. Now we want to match it and create a condition, so that later we can use the condition in any microcontroller, because serial port communication is very generic. Any microcontroller can support and you can use it from any microcontroller. So for that we need to store this value in some place. So instead of printing the serial print here, what I will do right now is I'm going to stitch them into a variable. Okay, so I don't want to print it right now. I want to store it somewhere so that I can use it at some point. So I have to, that doesn't matter right now. And then I want to check if the stitch string equal to the number I'm looking for. So this is the key. This is the thing we are looking for, and for that all this hack, everything. Now we got this, and then we can say what it means. So let's try to understand this code also. See, pin number 13, output is high. You see this is 13 and 1. Now let's change it to low and click on this. You see everything is same, just this 1 became 0. Try one more thing. Pin number 13. Let's make it pin number 4. Now click on this. See, 0 is for low and 4 is for the pin number. So that means this is the constant part of this packet and this is the variable part based on the pin number. To validate that, maybe we can do one more thing. Set PWM pin and see, click on this. Oh, 502 is same, 31 become 32. Oh yeah, so this is the pin, this is the number that says what block you are executing. And one more surprise, you see this weight. I told you before in the storytelling that this weight doesn't matter to the driver. So if you click on the weight, see, nothing is going to the Arduino. This wait means to you, the PictoBlox, to wait for some time and send something or tell something to the Arduino. So that means this wait is your personal message, you are not going to send to Arduino. Okay, so with that understanding, with this I want to print a message, and that is I see not something, I know what I see now, right? I see pin number 13 is high. Okay. Then I know the pattern, right? So I don't need to sniff anymore for these two. And else if this is 0, then it is low, and else if 32 means you, what is this? Oh, this is the pin number. Okay, so pin number 3, just take for example, and 32 3, and then this is the value. Okay, so this is another thing. So PWM pin has analog values, right? So it have to send not 0 and 1, it have to send 0 to 255, any value. So let's take it to 55 just to test. And then what we're saying is, okay, high and low, and let's see pin number 3. So I see PWM pin number 3 is getting, it's okay, understood. So let's flash the code. First I'll start high. I see pin number 13 is high, and then this one. I see pin number 13 is low, and then you see PWM 3. I see pin number 3 is setting through 55. We are able to detect what we are clicking, which block we are clicking from PictoBlox. Now we have this idea which button triggers what signal. With that in hand, we can remove all the Arduino and bring our brand new Arduino Uno R4 and let it operate by PictoBlox. Are you excited? Let's wait for the next video. Thank you so much.